Okay, welcome back from the break. So before we get to the whiskey, the next thing on the agenda here is panel discussion like we had yesterday, but different topics. So I'm gonna let these folks maybe just briefly introduce yourselves quickly, sort of where you come from, your perspective, and then the topic, and then you can take it away. So thanks very much.
Hi, my name is Lenny Kouwenhoven. I'm from the Netherlands. I work for PAC, and my background is chromatography, but then more, Dean's column switching or 1D chromatography. And since a few years, it's GCxGC is added to it. At PAC, I'm the project manager for standardization.
Good afternoon, everyone. My name is Bezuijen². I'm a colleague of Lenny, also working for AC in the Netherlands. And what we try to do with this application is bring something that is not really research and try to develop it in such a way that it can be employed in routine laboratories, where this method is the result from. So we're very happy to discuss with you what we can maybe add and improve on this application.
Hello everyone, good afternoon. My name is Peter Wotka. I'm an assistant professor in California now, but my whole background is in fuels, starting with my bachelor degree. And I know that many of you folks, you don't work with fuels, although some of them smell very good or very bad, very bad. But this is a huge deal for the whole GCxGC community. Like GCxGC being implemented in ASTM is really an amazing step. So I'll be really looking forward to some of your opinions and discussion.
I really like the setup yesterday. Did a few questions. But this is my first time at this conference, so we prepared it a little bit differently. The title for the discussion is did ever be in common use in petroleum laboratories. So it is probably a continuation of yesterday, but then focus on petroleum laboratories. The first ASTM method was published in April 2020, so that's only last year. So you can imagine that we still have a long way to go before it is really trusted and maybe implemented as a routine analysis in petroleum laboratories. You've been working with this technology for way longer than we do. So this is a discussion we really hope to learn from you and get your ideas on how we can speed up the process of adoption in petroleum laboratories. So we'll start with the presentation and then we have the panel discussion. So the agenda is that we'll start with the story of D8396, the method for group type analysis in hydrocarbon liquids. It's tested for jet fuel, and the group types are normal paraffins, isoparaffins, naphthalene, monoaromatics, and polyaromatics. After that, a little bit about data and statistics. The rules within ASTM are very strict, how you collect your data for precision statement and how you do the statistical evaluation. So I want to go a little bit through that. Then Job will take over the presentation and show a little bit more in depth what the ASTM method is and where we are at this moment. And then the panel discussion. And I'd like to recognize two people. They both committed to be part of the panel. One is Christina Kelly, couldn't come to Belgium for personal reasons. And the second one is John Sims. He is responsible for fuel quality at Exxon and knows a lot about statistics. So he would be really a good asset in this discussion, but he tested positive on COVID on Saturday. So he sent me this message, I can't come, and he's actually pretty sick, so I wish he will recover quickly. So I'm very happy with Pieter to step in and be one of our panel members. Before I start with the story of D8396, a little bit about test methods and why they are so important for the petroleum industry. I'm sure every market has its own requirements. We heard this morning about pharmaceutical, other requirements. But for petroleum, standard test methods are really important. I would say it's almost only used in those laboratories for two reasons. First of all, safety. Second, cost. Now, safety, you can imagine if anything is wrong with the fuel and the lab reported the wrong results, anything can happen. You know, if it's jet fuel, you don't want to be in the plane. If it's your car, you know, there are huge warranty claims, for example, on injectors when the fuel quality is not okay. And of course, when cars get stalled, nobody wants to read that in the nose. So that is safety, but also cost. Normally, petroleum products are always sold in and traded in big quantities. So if there is a test showing a different quality than what was promised, of course, you know, high cost is involved. Those things. So test methods are used to measure quality, any point in the process. They are used also to monitor the processes. Refineries rely a lot on historical data, so it's important that data is produced over a longer period the same way. It's used for specifications. As an example, like in Europe, gasoline, that is well described in a specification, partly because of EU rules, partly because of requirements for the car industry. And when you drive from Norway to Greece, you can rely on the same gasoline quality for your car. So that's all like European organized. Same for the US. You know, the Clean Act describes exactly how fuels should be. But of course, you know, to prove that the fuel is on specification, there are test methods and referee methods to prove that, for example, the gasoline is RON 98 and not 96. Those gasolines at the gas stations are regularly tested. So if you produce off-spec product, you know, there are high fines. So again, when two parties need to prove a certain quality, both parties need to be able to test the product similar, and then the results should be similar within the limitation of the statistical analysis, of course. And then, I said that before, the government and regulatory agencies nowadays with our Green Deal and the Clean Act in the US, you know, it's a very strict measurement. And nobody wants to report wrong results. Too expensive. So, this one. So then now I start with the story of the D8396. I call it step one. So that is the idea phase. You know, and then I mean PAC, we develop all kinds of applications on request of the refinery. So we saw a need, but also discussions at ASTM. There were discussions about we need an analysis with more, of which results in more information about especially diesel fuel and jet fuel. So most of the methods for those two products are performance-based, but there was already a need, especially with the coming of all the renewables, more information about the composition. So group type analysis for those fuels. ASTM said, why don't you do it? You know, you're here all the time, so why don't you take that task? And since PAC already had some instruments in the field, I thought it is a simple task, we can do it. In the end, it took 3 years. We are not done yet, but I think it's a very interesting project. So we decided to start the process and decided that we would go for a generic method. So in standardization, you have two choices. You can write a test method specifically on one instrument from one vendor, you know, type of define every little step what to do to get to the result, or you decide to develop more a generic method that more suppliers can comply with the method, that it can be bought at more companies and that kind of thing. Now, in this case, we decided to go for the second one. It's a faster process, because if your competition doesn't like it, when you write something that only can be bought at your company, but of course also the market doesn't like it. If they are forced to use it for, when they are forced to buy it from one company. So we decided to go for a generic method. Some limitations, so we decided to do flow modulation and reversed phase and FID. But the choice of columns and software or that's all up to the user. Standardization and validation of the results is then through reference material. So we have gravimetric blends and also fuels, and one will need to pass those fuels correctly, and then they comply with the method. So with that, having that, we had to go and look for an organization who would, let's say, facilitate the process. And I say facilitate because all those organizations that are the global organizations, they don't do method development themselves. So they only facilitate the process. So the stakeholders, they develop the methods. There were a few choices. Of course, first of all, ISO. It's all well known from ISO 9000 and such. It's a global organization. They have an active technical committee for petroleum, EC28. And the members of ISO are all the countries in the world, or almost all countries are members. So the national standardization bodies of a certain country, like DIN for Germany, is a member at ISO petroleum. We also had a choice to go to CEN. CEN is the organization who develops the EN methods for Europe. And then the members are the European countries, plus a few extra, like Norway, Turkey, Israel. They are also member of CEN. And of course, we have ASTM. ASTM is well known within the petroleum industry, but it's an American organization. And here you can see that ASTM is part of ANSI, and ANSI is part of ISO. DIN, we said before, is part of is part of CEN, but also part of ISO. So it are three different organizations, but people go to all three and try to influence all three. And why are they still so focused on having their own method is that everybody wants to control its own method. So if the CEN has, for example, a method for sulfur in gasoline, could be an ASTM method, but then they lose the control about the content of the method. So everybody wants to control their own method, especially when it is defined in specifications. So we had choices, but the discussion started at ASTM. So ASTM was the first choice, and also for another reason, ASTM allows or has a very low threshold to start with method development. So they allow an interim precision for the first 5 years. ISO and CEN will only start method developing or facilitate method developing when you're completely done and have a full precision statement. And later you will hear what that all entails. So for the 8396, we decided to start at ASTM. So we found ASTM, but then ASTM, of course, is also a very large organization. They have groups for anything, for toys, paint, anything. But for petroleum, it is DO2. And within DO2, there are again a lot of subcommittees, task force, committees, sections. But there's one specifically for hydrocarbon analysis. DO204. And within DO204, there are again different sections, and one for chromatography, gas chromatography, is section section L. So, for example, liquid chromatography would be section C. So every technology has its own, section. So for the GC times GC method, the best section would be DO204 section K. So we went there, or we are a member of that group, and that group meets twice a year. Actually, the whole DO2 meets twice a year. And imagine that it's somewhere in the US, in a large hotel. They rent the whole place, all meeting rooms, and then like 1,000 members, they come, and there are several meetings at the same time. You can walk in, out, and discuss all kind of methods. You can bring up analytical problems, discuss renewals or changes in method, but also discuss new methods. ASTM is big, especially in petroleum. For example, they have done 800 standards under their published, and those standards are at least every 5 years checked if they need to be revised or not. So ASTM, so we went to this section K and presented the idea, and then section K, sorry, I say K, but it's L. Section L, there are like 50 people in the room, and they are all stakeholders. So it could be from the, in this case, from the refineries, from the contract labs, from the car industry, companies like us. Everybody who has an interest in chromatography and petroleum is the program online. So we presented it, the committee said they were interested in it, so they said they allowed us to open a work item. Once you open a work item, it is like an official project for ASTM. And then the work starts, because then you start writing the method. And it is a kind of a standard template. All these sections on the screen are like mandatory paragraphs. I want to explain a little bit more about the ones in bold. So the scope is important. If you ever decide to standardize a method, the scope is really important to define exactly what you intend to do and what the final result should be. So if you want to make a test method for diesel fuels and jet fuel and for diesel fuel and jet fuel, for example, then make sure that the scope and the testing is on both matrices. If it is the concentration range between 10 and 20%, make sure that you test it for those concentration range, because the scope will contain all the information, what the method is meant for in what concentration ranges. If you later wants to be part of the fuel specification, you have to make sure that it covers the fuel specification, for example. Of course, you have to say something about the apparatus, how to do the analysis, and so that would be the procedure and then a precision. For ASTM, this precision is first an interim precision, and that is a limited precision from, in this case, from our laboratory. It's also very important to write exactly what needs to be done, because the more strict the procedure is, the better the laboratories can follow that procedure, and the better precision you can expect. So it's always that balance on how much do I write down, how much is for the own interpretation. So when we wrote a method, then there is this acceptance process, and that is through balloting. There are two stages. The first stage would be a subcommittee ballot, and the second stage would be the main committee ballot. Subcommittee, that would be generally that are the experts, so they really know the technology or the application, and the main committee, that is the whole community, and they could have a different interest. So the first step for us was to submit our method to ASTM, and then it is like electronically distributed to all the members. They read it, they have a month to read it, and they can comment on it then. So one thing could be, one of their reaction could be, I don't know anything about it and I'm not interested. They vote abstain. Some people might say, well, oh yeah, I like it and I totally agree with it. They vote affirmative. And some people would say, no, this is not good, but it's minor, so they could send in a comment, and then it's up to the technical contact to implement a comment or not. Or they say, no, this is not good, it has to change, and this is my proposal how to change it. And that is called a negative. Now, in ASTM, it's 100% agreement. So if there's one negative, one person, anywhere in the world, you have to start a discussion with this person and resolve the negative. And if you really can't resolve, you tried everything, you can go back to the committee and try to have it voted as non-persuasive. But that is like your last thing to do. You first try to really negotiate and come together to a solution. Now, the same process with the main committee, and I said that people with different interests. It could be, for example, people who are responsible for fuel quality. They look at the test methods differently than the laboratories. For the 8396, it took us 8 rounds of ballots. That's a lot. That's a lot. And it was not so much that we got comments or negatives that they did not agree what we wrote, but it was more people wanted more than what we wrote. So we started generic, but that was kind of not accepted. So we had to put in more information on how to use the software or how to set up the instrument. So we added a lot of information. But we also got comments and negatives, for example, from the GCxGC community. We made mistakes with terminology, so we got comments on that. So with those 8 rounds of feedback from both groups, so the sub and main committee, I think the method became way more valuable. For us, it was also the first time, so I think it was really worth it. So I said already before that ASTM is a bit different than SEN and ISO. And this is kind of an overview of what the main differences are. So ASTM, that are the industry members who vote. So you deal with individuals. And for SEN and ISO, the members are actually the country, so they vote. So it's not depending on one person, but it's on a whole country. And then those votes are even weighted. So if the larger countries vote positive, then you still can continue. At ASTM, you have to have 100% agreement. And SEN and ISO, it's 71%. Precision, very important. If it's a new technology, start at ASTM because you have some room the first 5 years. And for ISO, you have to start with a complete precision at start. Meetings, ASTM is very organized, so it's always the 3rd week of June, 2nd week of December. You all know for the next 10 years where you will meet and what days. And SEN, it's more on a need basis. Method updates, at ASTM you can update the method anytime. That's also a complaint from SEN, so it could be twice a year, and then SEN also has to update their methods twice a year. That's why they prefer their own methods. And the ballot process is similar, so it's at 2 stages. In ASTM we call it sub and main, and in SEN we call it inquiry and formal vote. But anyway, after those 8 rounds of ballots, we were through, and the method was published in 2022 in April, ASTM D 8396. We continued, and actually this was the section for John Sims, our statistician, but because it's all about precision. We continued, so I didn't want to wait the 5 years. We were going to work on a precision statement that is a repeatability and a reproducibility calculation. And for that data, we were going to organize an interlaboratory study. All is really in detail described in ASTM method D6300 and ISO 4259. So for the repeatability, we are looking at how well two results compare when the same materials used, the same procedure, the same lab, same equipment, same operator, and on the same day. So, for example, when we divided, we're sending around our samples, we had to make sure that people could do the samples on one day. For reproducibility, we're testing the variants, for the same material, the same procedure, so the same test method, but then a different laboratory, different equipment, different operator, and maybe the same day, maybe not, we don't know. Requirements for an interlaboratory study. It's quite a big study. So first of all, you need a strict protocol. It's different from those round robins. Then you can run the sample according to your own method. But for this, in this case, you need a strict protocol, and the members should stick to that protocol. Protocol could be the test method, or it could be the test method plus some additional requirements. Minimum are 6 laboratories and enough samples to get 30 degrees of freedom. That's something we cannot get around. 6 laboratories is really the minimum. For the 8396 we use 21 laboratories and 21 samples, just to make sure we get the right number of degrees of freedom. And also in this ILS we will test the different setups. So it was a generic method, so people could use different columns, different modulator, different software, and we wanted to test how well all these variables compare. The method shall cover the range of the method, so the percentage, if it's 20 to 40% what you want to test, then those samples need to cover those samples. So you really have to design your ILS well and make sure that all matrices and ranges are covered. Samples shall also be blind coded. So the participants, they receive, for example, 2 files from the same sample. So it is a blind replicate. And also 2 laboratories will get different codes. So sample 1 for one lab is not the same as sample 1 for the other lab. So neighbors cannot discuss results. It's all the rule from those methods. Then again, these are the methods we use for the statistical evaluation. Now, variables, what we have to focus on, and that will also be a question later in the discussion, we really have to control all these variables in order to get a similar test results. So environment, equipment, operator, procedure, material. That's what we need to control when we determine the precision, reproducibility. This is an example of a precision statement. So it says now the parameter, the repeatability at a certain level, and the reproducibility. And then the last is the importance of precision for the fuel specification. Like us, as a company developing application and instruments for the petroleum, our ultimate goal is always to be mentioned in the fuel specification, because that is like the highest you can reach for. So then you know that the fuel specification, for example, in this case, let's say the sulfur content is 10 ppm. Any instrument or application you develop should at least cover those 10 ppm well. And then you make a chance to be accepted in fuel specification. And then I hand over the mic to Job for more detailed information.
So for slightly more details on the method, and I know you guys are dying to start analyzing those whiskey flavors, so I'll try to go through it quickly. So first I would like to share a little bit the background on why this method is important. And we realized this only after starting the ballot process. So initially our application was developed for middle distillates, but we found out that most of the interest in this method was really coming from the jet fuel people. And the reason, and this has been mentioned before in one of the presentations, obviously, is that the hydrocarbon type composition describes something about your fuel quality and your combustion properties, burning efficiency, soot formation. And the other thing is that it is particularly the aromatics content relates to the compatibility with the fuel system. So in the fuel system in your car, but also in airplanes, there are seals used, and those seals, they swell a little bit upon contact with aromatics, and make sure that you have a leak-tight fuel system. And actually, right now, the jet fuel composition in the market is changing. So historically, with all the petroleum-based jet fuels, you had maybe 30, 25, 30% aromatics, but to be able to reduce the carbon intensity of aviation, synthetic or sustainable jet fuels are being developed, and because of the process, those fuels are very low in aromatics, and actually that's why petroleum-based fuels have a maximum limit on aromatics, but synthetic fuels, they have a minimum limit on aromatics. And there are currently about, I think, 7, so this lists 5, there are about 5 to 7 pathways that are certified within ASTM to produce sustainable jet fuel. And the most important one is currently called the HEFA process, so hydrotreated fatty acids. And there are a few manufacturers across the globe that produce sustainable aviation fuel with those technologies. But there is really a lot of research and development ongoing in certifying more processes. And for aromatics in jet, for hydrocarbon type content of jet, there are 2 specifications that govern those. ASTM D1655, which is the standard spec for jet fuel. This is kind of linked to the DEFSTAN 9191 spec that's being used in the UK, so they're harmonized. And they list a maximum content of aromatics, 25%. But for synthetic jet fuel, there are additional requirements, and those are described in ASTM 7566. And actually, it's a 2-step process. So you have to certify your pure synthetic jet, which is very low in aromatics, so you can see the specification limits there. And then, because it needs to contain a minimum amount, you need to blend it with a aromatic based stream, which can be traditional petrojet or something else. And then it lists an 8% specification as a minimum. So in those, the test methods that are being traditionally used is column chromatography or HPLC. And for those 25% of aromatics, that's perfectly fine. But as soon as you go lower in concentration, those methods don't really perform that well. So here you can see the different specifications, 1655 and 7566 with the methods that are being used. The most common one is really liquid chromatography. For synthetic jets, there is a MS method, 2425, very old one, using column chromatography as a sample prep. And we think that for both these applications, GCxGC can be a better performing alternative. So as Lenny mentioned, we got the method published in April 2022. The scope is probably not readable, but as Lenny mentioned, it's quite critical in terms of getting your method accepted in the industry. So it needs to describe very well what it does and also what it doesn't do. So there are some disclaimers there. And you can see, I think I have a slide later on as well, that there is also a range listed in which the method can be used with an interim precision statement. And this is actually based on the analysis that we did in our lab. So we decided to write a generic method, as Lenny explained, for flow modulation. So this is a trimmed down flow diagram to help the user a little bit understanding what needs to be done to set up this instrument. And obviously, if you are going to write a standard test method, you have to think about how to standardize it. So there should be certain criteria that you have in the method that allows users to validate if they can meet those criteria, yes or no. And I think this can be part of the discussion later on, because in traditional, one-dimensional chromatography, we have resolution criteria or sensitivity criteria, which cannot be easily translated into the 2D realm. So what we decided is that we would create a gravimetric blend, which is the top sample that you can see, where we know the concentration, and we can use that blend to verify if you're basically to qualify your instrument to see if it is behaving as you expect. So in the method, we use theoretical response factors, and by using this matrix, we can qualify if your instrument performs as you would expect. And then as a second step, we have a real-life sample. We have accepted reference values from limited round-robin study, and those you will then use as a validation of your instrument. So that means that the largest or the most important driver for standardization in this test method is actually driven by those two samples. And there is room for improvement here to do it in a better way, I guess. So this is the interim procedure statement, again described in ASTM D6300 how you should do it. And this is, I think, 3 different samples that were in our lab, 10 replicates or something. Currently, so because once we have the method accepted, as Lenny explained, we should start work on a precision statement to make sure that the method can be actually used for custom transfer operations. And that's what's currently ongoing. So we are running a quite extensive ILS. Normally you have problems finding participants, but in this case we have rather too many than too few. So that shows again that there is a lot of interest in this technology and in getting it out in the market. And there actually we have all kinds of different users. So we have people using cryomodulation, normal phase, different software packages. So we are really trying to see how that influences all the the analytical performance of the method. One other thing we would like to find out is because for this synthetic jet fuels, this detection limit for the aromatics is quite low. So there is a specification of 0.5 mass percent. And we want to verify with this ILS if that is a limit that we can practically achieve in the field. It's called the pooled limit of quantification. And again, the different software packages we have seen have a slightly different approach of integrating those very low levels of components, and that can actually influence the result quite a bit. So we have about 21 ILS participants, which is really a lot. 6 different jet samples, 8 synthetic jets, and 8 diesel fuels. We have about 18 results submitted yet. The initial evaluation of the data shows that the variation is much larger than we had hoped for, and it's actually not good enough really to go further with the method development. And we are currently in discussion with all the participants to see what we can do to further improve the reproducibility of the test method. So we had a discussion a few weeks ago, and we are having another one planned for mid-February. And maybe Lenny, you want to comment on it, but so obviously the performance criteria are one thing that you need to standardize, and the other one is which is a little bit susceptible to interpretation, is the setting of the templates. We have seen some nice examples today how they can be automated, but it's currently not practically feasible in the fields yet. So that brings us, to you guys. Having heard all of this, do you think that that you have tips for us that we can implement in this method to further improve the performance? I'm not sure if you want to add anything to that to the audience.
Well, I have not much to say. What I'll say is we collaborate with a few petrochemistry companies. They already using GCxGC in their lab to evaluate the fuels. Most of them using it for the pyrolysis oils. So there is a huge company called Unipetrol in Czech Republic. So they have a research department. they're already using it. But the question for the audience is like, because most of you using the GCxGC, if this should be a standardized method, what would you like to see in the method, I believe, and what would be basically the reproducibility data you would be happy with to use? Just please remember that we don't distinguish the carbon numbers. All the isoalkanes are grouped together. I think they are actually grouped with paraffins, right? And alkanes. So all the cyclonaphthenes are grouped together in aromatics as well, mono and poly. So that I think will be the part of the discussion. Or do we have more slides?
No, this was the slide. There was one more slide, which I think was from Lenny's presentation. So obviously there are a lot of factors that can influence the variability finally in the end result. And in the procedure and the equipment. So if you have any suggestions for us to further improve the method, or you're interested in discussing with us about the details, then please let us know.
I'll actually start with one question that we talk about during the coffee break. I know everyone's looking forward to the whiskey break, but I'll start with one question. That's regarding the helium hydrogen. So this method was written, as you could see, for the helium. Some of you using hydrogen, most of us will be switching to hydrogen soon, or nitrogen, something else maybe. How confident would you be, and there are a lot of ASTM, ASTM methods, how confident would you be in, if the method is written for the helium, how confident you would be to using it, although you're using hydrogen or different clear gas? So basically, I'm asking any experience with running similar method with, helium or different clear gases. Oh, that was good.
Well, we are going to make an analysis. You see the disease to be level for conditions in the left center. If you want to see study for the method of 55, you should also so there's a matter of this sort of definition about whether we want to look at this now, and the reason we showed it is that this is the reason I need to see that for some standards, of course, we might have information we have not need to do response to it, and this is we use code, so it's very high level of segmentation. You need to be able to come up with your target points. And we have one this I was actually targeted, so I want to see it. And the government to that with the protocols that GCxGC design. A lot of this is that I need to control of its sense, just of the concept, and indicate that the concept I think I don't have possibility. Now, and it's in Yes, thanks. That's a first statement, and the method allows flexibility in column surveys, as you mentioned. So as long as you meet those reference values from those two samples, and it looks promising as the work. Thanks for
You go first.
So there are no usage criteria. However, and that's also looking a little bit to Lenny, we do suspect that there are differences in results because of the software that's being used. So, and we're not sure how to handle it. That will be part of the upcoming discussions with members of this alliance. But there are no requirements in ASTM that you should use a specific version software.
Yes, I think it would be very limited if there are requirements with software to use. Very unfair to probably different vendors. We've seen differences between, so Chromatov takes the peak area, right? The GC image takes the pixel area. So we see differences in this. What we discussed last time was that maybe we can share the data, and different groups can process them different way to see how that would affect the reproducibility. So that's a great suggestion. Yeah, but in the method in general, there are no specific requirements with software to use. So I think using MATLAB would be absolutely okay.
In this ILS, we had several people using GC image, Chromatov and ChromaSpace, and 3 in-house softwares. And then 2 I expect are the same. It's from the same company, and 1 is a different company. So we really have a nice variety of software packages. And then when we share data, people get data from another side. Some people picked specific data because they was very different from their own data, so they asked for their data. That's going on right now. So, with the first, just visual analysis, I could not see difference between thermal modulation and flow modulation. Could not see any difference. Could not see difference between, or could see a little bit difference between normal phase and reversed phase. Normal phase seemed to be better, although, but it was only 3 out of 14. And those normal phase people, they were also using in-house software. Yeah, so it is something to keep in mind, but it's not, it was just not enough to make that judgment. Columns, everybody used different columns. Everybody. So there's no way I can analyze the results based on columns because everybody used different columns. What else if we look at software? But that's it. Yeah. So first we're going to share data, see if that makes a difference. And then next step. The repeatability was really good. Reproducibility was not worse than the existing methods, but we want to be better. So, we have the time, we have the people who are willing to spend time on it. So we like to make the method as good as possible, and then we can put all this information into the method. So new users can learn from all these experiences. That's it. But what did you do to be convinced of the technology? Or how did you, for example, I said it yesterday, when we put up those 2D plots in one of those standardization groups, a lot of experienced chromatographers, but still they look at what's this? Doesn't look like output from a chromatograph. So what is your experience? How do you explain it, or how could you convince other people, about Yeah, let's say the power of GC times GC. Is there anybody who can share their experiences with us? Because that helps us to convince this petroleum laboratory people.
Yeah, so the petroleum industry in general is quite conservative. So one of the three investment methods,
Yeah. Yeah, I think Michael can say something.
So once they get control, the and then practically they can use our scope easily running the our this is the idea that's why it comes together. We are not challenges, the new challenge in the generation of the government. Scaling up of we are running as much as we can. We are running about GCxGC and now we must be more needed than people in the or more than properties of these new products. Are really a lot of estimates and volumes. They want to be most of all to unshut you can handle the power. These are people now the new product they have the knowledge pressure after the legal system they are looking for an hour.
Yeah.
I don't want to be more powerful compared to the situation. So you can come to us. Without that, they not really need or absolutely more data. So there's one is easy. ASTM trying to push for standard needs or normal phase GCxGC.
Yeah.
They need a new concept of if they need and run then
New technology. Yeah, before us, I think there were 2 other companies who tried to standardize the ASTM cable. One was Shell, yeah. But now they support as well this method. Shell is supporting this really good now. Yeah. Yeah, there are several participants in this group. So Total, thank you for also donating sample and participating. Sims³ is helping us out, LICO, and University of California. So it's I think these 21 labs, it's not just from the ASTM community. It's not only research. We really have a mix of university, research, some contract laboratories. Yeah, so we have a nice mix of laboratories in Europe and US, so that's good. Yeah. Yeah. But these 3 normal phase, they also had the in-house software. The 3 normal phase laboratories, they also had in-house software. But that was also different from the others. So we still. Yeah, during the next teleconference with all the participants, but also some other people participate in the phone conference, in the discussion, we definitely going to discuss blank subtraction, how to deal with bleed, and then we probably will invite the software vendors to explain their algorithm. Oh, testing.
For the quantitative analysis, which is that analysis will be showing that 10 days, so it's starting to multiply of carbon techniques. And usually starting from this method in the third commercial lab, the data are really GCxGC. And it's been maybe 2 years now, or so I'm not sure, but we have a lot of progress to track what happens in the long term, so we establish the method, and it's basically part 12 at the beginning, but then after the change in the sharing the drug recommendation, and on the secondary phase, for every more. So if you just want to establish control charts, which will be adapted to data, that the question help us a lot. We realize that we are out of the and when we help us there about underlying period and the typical needs for platform where today are there online variation is acceptable. So yes, it is going to be shared.
Yeah, so thank you. I think those are valuable comments, and I think they relate to what we also see in the ILS. So, and I asked the question already before. So currently we are looking only at this reference sample, but if there are suggestions to add additional criteria where you can qualify your method with, that would be helpful. As you know, analogy is obviously the resolution in 1 DGC.
Yeah, in terms of quality control and repeatability, obviously, hopefully that will come from the study to see what is acceptable, yes or no, in terms of a deviation of results.
Better to be the temperature, the global composition of that, and also in the basics changing our results, change one, and it's now also very easy, which are not really very good, it's very good to have basic, you be representative of what you are returning. It's really different to PO source or return style. People will be there, like, it's very good to find.
Yeah, I think we can second that, yes. Yeah, so if you have a different matrix, obviously you can start to see some overloading of peak shifting, and that will affect your templates. So we can second that. It would be nice if there would be a way that is standardized across the industry how to go about these questions. So, thank you.
But I hope that these 21 participants here continue that journey with us to make this method better. It's a matter of running samples, discuss, improve, open up. What did you do? What is good? Share good practices, and then you'll get a good method. And remember, the existing methods are not that reproducible. So our target is not so high. But we want to have it like the best as possible. We want to learn from this study.
Like people really like, and really like also on people being involved in probably for the 21 meetings. I think we can also see like that can be really challenging, but I really encourage your like discussion and other ones the units, and I think it's all of us who benefit from that activity. So I guess just to say it with you, because it's something we try to be something like this before. It wasn't going as planned, and I hope that will continue because it seems really interesting for everybody, not even just for those who need to be on the house.
Yeah. Now we started like, okay, simple job, we can do it. But then we saw the reactions from the industry, from this community, so we presented at ASTM, but we got questions even from China, from Europe. They heard about it. So it is something what we see the market is interested in. So definitely we will continue and finish the project. Yeah.
And so your question about how do you, why or how do you convince, I think it's a very good one, and I would say from the PLC community, we don't know. I mean, because we've never done anything like this before, and if you don't have the data, we're convinced to do that. But we don't know. And I think in 1D LCS, there have been such large theoretical studies, and I think that's still an issue. So, but I think what we're lacking now in the LCD is something larger than that, this organization or driving force to make it happen. So I agree with you all outside of the community, outside of the GCxGC. So we are
more or less at the end of time. Any last comments or questions?
Maybe if anyone wants to be more involved, just contact us. You can get samples still. We have a lot of samples. But if you want to be part of the discussion, that is fine too. Want to say something? We're done. Yeah.
Okay, well, let's take our panelists here for a brief question. All right, so now to other things. So thank you again. So the next last event for the day, I guess, is the whiskey event, and sponsored and hosted by LECO. So we have Lena here from LECO to tell us how it's going to go.
Well, I haven't covered last like with you today, just like the top of this program here. Probably you have about one already. Now we will go up and do a list of existing now. So we will start quite officially, but you can start to move up and you can see everyone is there. We will go and start with. If you're not interested in whiskey or drinking, there will also be a science talk. So you all have to know numbers. But yeah, we will have some whiskeys to tell